Hello everyone, and welcome to your brand new unit on transformations. We are going back to chapter 1 and looking at 1.5. This is going to be probably a kind of long video because I'm going to go through all the different transformations and then at the very end do an example of what I'm looking for. So feel free to watch this at double speed. Let's jump right into it. So over here we can see that we are looking specifically at vertical shifts, so that means up or down. So if we have some function with a plus some number at the very end, well, if that number is greater than 0, then we are going to say that we are going up by that many units, and if k is less than 0, then we're going to be moving down by that many units. Now, since it is affecting, it's going vertically, it's going to affect the y values. So we're going to specifically be looking at the y values. So in this first example here, we're going to graph f of x plus 4. So that means that we're going to be moving up 4. So if we take a look at this table over here, these are the points that we have for this original f of x graph right here. And then for all of our y values, we're just going to add 4. So if we do that, that first point is going to become 8, 16, 11, 14, 17, and 13. So when we graph these, we're going to use these same x values, nothing happened with those. We're going to be using these new y values. So you can use that for the table, or you can just count up 4 each time for each of the points. And we have our new graph. Try to make this as pretty as possible. So this purple one, that's our original f of x, and our new one is f of x plus 4. For example number 2, now we have f of x minus 2, which means we are going downward. We're subtracting 2 from all of our y values. So in the table, that's going to be 2, 10, 5, 8, 11, and 7. So again, we're going to be using these as our x values, and these are going to be our brand new y values. So you can plot all these points, or you can take a look at the graph and just count down by 2 for each of these. So what I like to do is I like to make all my points first, and then connect them. So that purple graph, that was our original f of x, and this new blue one, that is f of x minus 2. So that is all of our vertical shifts. Let's move on to horizontal shifts. That'll be on the next page. So horizontal shifts, these are moving us side to side. This is going to affect our x values. And anything horizontally or dealing with x values is always going to go the opposite way of what we think. So here, when we see something plus or minus inside with the x, it's going to be a horizontal shift. Now if h is greater than or equal to 0, then the graph is going to move us to the left. And if h is less than 0 or subtracting, it's going to move us to the right. So for instance, in example 3, we have f of x minus 6. So even though that's a minus sign, we're going to move us to the right. Now, the tables that they do for these examples, I don't like the way that they do the horizontal ones, so we're just going to cross this out, because I don't know why they have it on the y value side if it affects our x values. So what we're going to do is, even though it says minus 6 in the equation, we're going to change the sign, and we're going to add 6 to all the values. So whenever you're getting help from the table, you're going to change the sign. And then, so let's see, if we add 6 to each of these, that'll be -9, -3, +3, 9, 15. And I'm going to ignore this last one because it says undefined right here. I'm not exactly sure why it does that. But if it says undefined or if it has an X on it, I'm just going to cross that out for now. You're not going to have to worry about that when we do problems. So you can either use these as your table, where this is your new x value. We're going to keep the same y values, or you can count over 6 units from your original points. So let's see, that'll be here, 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 and here. Looking something like this, where the purple one is our original f of x, and the blue one is f of x minus 6, showing that, hey, we've moved to the right. I don't want to make this video too long, but if you'd like to go over the reasoning for that, just ask me in class, we can go over that. And then our next one, example 4, f of x plus 12, since this is positive, h is greater than 0, it means it's going to move us to the left. So you can count 12 units to the left, or if you're using the table, I'm going to scratch out this part again, because why are we changing the y values when all we care about is our x values? So I'm also going to take out all these things that say undefined here, because I do mine a little bit differently. So remember, when you are dealing with x values, we got to flip stuff. So we're going to change the sign. Instead of being plus 12, it'll be minus 12. I'm going to change the sign. So for us, that's going to become, let's see, negative 27, negative 21, negative 15, negative 9, and negative 3. So we're using these as our new x values. We're going to keep these as our y values, and let's count over. So let's see, there'll be a point here. There'll be a point here. Thank you for your patience. I'm still human, and therefore to figure out how to graph things in real time. And here, okay. So remember that purple one is our original f of x, and this new blue one is f of x plus 12, where we have a horizontal shift to the left by 12. So that is the very last of our shifts, but we have 4 more transformations to get through. One of them being vertical stretches and compressions. So again, since this is vertical, this is going to affect our y values. And with our y values, things tend to go the way we expect them to go. So if we have some multiplier out here, some number out in front of our function, if we say, hey, if that's greater than 1, then we are going to stretch vertically by a factor of whatever that is. And then if it is between 0 and 1, or if it's a fraction, we're going to compress. You might have used the word shrink in the past. It's the same thing. We're just changing the verbiage a little bit. So for instance, if we take a look at example number 6, we see that there is a 2 out in front of the function. So it means we're going to take all of our y values and stretch them or multiply them by a factor of 2. So our y values in the table become 8, 24, 14, 20, 26, and 18. We're going to keep those same x values. These are our brand new y values. So let's see, I'm going to pull my paper closer to me. It's going to be 8, yeah, 24, 14, 20, 26. Sorry, I am just kind of muttering to myself as I do this. There we go. So we'll notice that the graph is now really tall. So the original one is f of x. The new one is 2 f of x, where it is now twice as tall. Same x values, just different y values. So that's an example of a stretch, while a compression, like you'll see in problem number 7, or example number 7, we're going to be shrinking our y values. So if I look at the table and I multiply all the y values by 1/4, it's going to be 1, 3, 1.75, 2.5, 3.25, and 2.25. So we have some decimals here. That's okay. We're going to just graph these the best we can. I am, however, going to zoom in just because it's difficult to graph from that far away. So let's see. This is our original f of x graph. If we use these x values and these y values, let's see, our graph is going to look something like this. That'll be at 3. And then we get into the decimals. Do your best approximation. So at -3, we're at 1.75. I know it's closer to 2, so it's about right there. Let's see, 0, 2.5, there-ish. 3, 3.25, closer to 3. And then at 9, it's 2.25, so about right there. And so we can see it looks like someone sat on it. It's a little flattened or compressed. So that is what a vertical compression looks like. But what if we do some of this horizontally? Let's change the page. So a horizontal compression, again, with the x values, it always goes differently than what we think. So horizontal is with our x values. Now, this goes the other way. So if b is greater than 1, so if it's like 2 or 3 or 5 or something like that, then the graph is going to be horizontally compressed. Or it's going to compress horizontally. And if it's a fraction, so between 0 and 1, then it is going to stretch. So the other way of what we think. Zoom in just a little bit more. So for this first example here, we have f of 3x. So remember, if it's 3, it's greater than 1, we're gonna compress it horizontally by a factor of 1 over that value. I'm going to highlight that just so that we can see. So it's going to be 1 over that value. So instead of 3, I'm going to be compressing it by a factor of 1/3. So when I write this in my table, I'm going to multiply it by 1/3. And again, I'm going to ignore this stuff. And again, I don't really like the way the notes do this. So you'll notice under some of the y values, there are just x's. We're just going to cancel those out. Don't worry about it. We're doing it just a different way. So I'm going to take all my y values, all my x values, multiply them by 1/3. So this becomes -5, -3, -1. That's going to stay at 0, and 1 and 3. We use these x values. We use these y values. And based off our original f of x graph, you're going to regraph this. So that'll be -5, 4, -3, 12, 7, 0. So you'll notice that the y-intercept stays the same because we're compressing everything horizontally, so that will not change. There we go. So here's our compression, f of 3x. So that is an example of a horizontal compression. Now a horizontal stretch, remember, that is also going to be multiplied by a factor of 1 over b. So here we have 1/3. So 1 over 1/3, that becomes 3. So I'll highlight that as well. I'm going to take this, I'm going to multiply it by 3. Now, anywhere where there's anything that's undefined, we're just going to ignore this. And I see undefined up here, and here, and here. So we're just going to deal with these points here. So when I multiply those by 3, those x values, I get negative 45, negative 27, negative 9, 0, 9, and 27. So this one's going to get really wide and really stretched out. Remember, these are our x values. These are our y values. They're going to look something like this. It's going to go there. Let's see. Something like this. So here's our original f of x, and now this is what a horizontal stretch looks like. And there we are. Got a little shaky at the end. So we've gone through all of our stretches and all of our compressions. The last thing we need to do is go through our reflections, because as you notice, as we've been talking about our stretches and shrinks or compressions, the compressions are when that value is between 0 and 1. But what if it's less than 0? Well, that's on the next page. So if you see a negative out in front, that's going to be going across the x-axis. Now this is a little tricky because it's going to go across the x-axis, but it affects your y values. And for the next one, if we have f of negative x, that's going to affect your x values. Oops. But that means it's going to go across the y-axis. So just be a little careful here. I think after we practice, we'll kind of see what's going on. So for the y values, this first one of negative f of x, all of our y values are going to become negative. So this is now negative 4, negative 12, negative 7, negative 10, negative 13, negative 9. If those y values had already been negative, we would have just changed them to positive. We're just flipping the sign. So if we do that, it means that it's going to go across the x-axis because that's where all the negative y values are. So that's going to look like this. Oh, that's not, go back. There we go, I just didn't have that lined up correctly. Now, some of these are part way through, and that is because the scaling is done by 2. So when we do the 13, it's going to be with 12 and 14. There we are. And we can see that it has reflected itself over the x-axis. So here's our f of x, and here's our negative f of x. All right, let's do our last transformation. So down here we have f of negative x, and that's going to affect our x value. So we're going to come over to our x value side, and we're going to multiply all of those by a negative 1. Cross this one out. So that'll be a positive 15, positive 9, positive 30, negative 3, and negative 9. So we're going to take all these points and reflect them over the y-axis because we're just switching which side the x values go on. So that's going to look something like this. Yay! So the purple one is our original f of x, and the new one is f of negative x. So this is an example with a very generic graph, doesn't have a specific function, of each of the transformations that we can be dealing with. So what are we going to do from here? Well, let's take a look at if we put all of them together. Here's kind of a summary of everything that we have. Now, on the examples we'll be doing, I'll do example number 12 with you. Those are going to be just like what I asked for in the coformative. I'm going to want you to list transformations in a specific order. So I'm going to want you to take a look at the function, tell me what the parent function is, and I've put pictures of those on coformative, or not, pardon me, not coformative, Canvas. So go take a look at that. But I want you to list the transformations in a very specific order. Now, generally, we do order of operations. Any type of multiplication would go first. So we're going to look specifically at our x values first. So we're going to look right here at those transformations. The multiplication, that's going to be our b value, which is our horizontal stretch or compression. So we're always going to list that first. And then if we don't have any horizontal stretches or compressions or reflections, then we'll go to our horizontal shifts. So in our orders, we'll look at those two things first, and then we'll take a look at our y values and go, okay, y values, order of operations, got to look at that multiplying first. So this would be next on the list of things. So this could be a vertical stretch, compression, or reflection. I'll take any of those. And the last thing we should be listing is our vertical shifts. So these are the order that I'm specifically looking for. But let me show you how to do a full problem. Let's see, problem number 12 gives us g of x. Do that, oh, there's my highlighter, okay. So this is our g of x. It wants us to identify the original function. Original function is the parent function. So let's see, for this one, the parent function is going to be, call it f of x, is equal to x squared. I see there was a squared in this function. Other ones I'm expecting you to take a look at is square root of x, x cubed, cube root of x, and the absolute value of x. So this is what I want you to look at. And then next it says, explain how the graph of y is equal to g of x is transformed of the graph of the original function. So we're going to graph the original function. We're going to list the transformations. That's the explanation. And then we're going to graph our new function. So I'm going to do a table off to the side. And I am expecting, I didn't change that. I am expecting you to know how to graph all of these parent functions. So for this graph, we're just going to go with the x values of -2, -1, 0, 1, and 2. And if I was to square each of those, remember this is for the parent graph of x squared, it's going to be 4, 1, 0, 1, 4. So if I graph that, it's going to look something like this. I'm just going to add the extra points just to make my graph a little bit prettier. And make sure you're labeling your graphs as well. So this is my f of x, or you can write parent graph. So that's there. And I'm going to look back here and see, okay, well, what's happened to it? First thing I want to do, let's take a look at our x values. I don't notice anything in front of that x. I don't notice a b value, so I'm going to skip that. But I do notice a -5 here. So that's going to be a horizontal shift. So when I take a look at my transformations, I'm first going to say what type of shift. So this is a horizontal shift. I'm going to say which direction. So this is a horizontal shift. Since it's -5, it's going to be to the right. And then I have to say how many units. So the first thing I see is a horizontal shift to the right, 5 units. Excellent. Let's move on. So that's all of my x value stuff I can see. Now let's take a look at the y values. So I look over here, there is some type of multiplication. There's a negative there, which means that there's going to be a reflection. So next I'm going to say, we're going to reflect. And remember, it affects the y values, but it's going to reflect over the x-axis. And then the last thing that I see, there's a +3 at the very, very end. So I'm going to list that type of shift. It's going to be a vertical shift. I'm going to list the direction. That's going to be up. I'm going to list the number of units. 3 units. So this is everything that's happening. So if I want to know how to do this, I can just look at my parent graph and count. But I'm going to use a table to help me out. So first I'm going to take a look at my x values, and I see that we're going to shift to the right 5 units. So remember, if you're doing this, you have to flip the sign. So I'm going to add 5. Here, we're change the sign. So I'm going to take all of my x values and add 5. So let's see, this will become 3, 4, 5, 6, and 7. So these are going to be my new x values. And then for my y values, I have 2 things going on. First, I see a reflection, and that means we're going to take all of them, multiply them by -1. Ooh, I did not leave myself enough space. And then there's a vertical shift up 3, so I'm going to add 3 to each of those. So first, if I multiply everything by -1, that becomes -4, -1, 0, -1, -4. And then if I add 3 to each of these, that will be -1, that'll be 2, 3, 2, -1. So this one over here, all the way to the right, is going to be my new y values. So again, you can either count that or you can use this transformations table. You're going to see me using that a lot, and it's in all my answer keys. So this just kind of helps me say, hey, this is what's going on. So let's see, while I graph this will be 3, -1. That's going to be 4, 2, 5, 3. It'll look something like this. So I can see the parabola. I can see what's going on. It's going to look something like this. Let me just check. Wait 1 second. Okay, so it'll be about there. I'm just adding in the extra points so my graph is a little prettier. Yay! And this is our g of x. So at the bare minimum, I need both of those graphs as well as the list of transformations. If it helps you to draw the table, draw the table. But bare minimum, I need the list of transformations and then parent graph or the original function and then your transformed graph. And that is what I'm looking for. So please let me know if you have any questions. I'm so sorry this video is so long. I'll see you tomorrow.